So you learned about 4 types of loops in C++. We talked about for loops, range-based for loops, as well as while and do-while loops. Now I told you that each of these loops has its own uses. Most of the time we use for loops in situations where we know ahead of time how many times we want to execute something. We use range-based for loops in situations where we want to iterate or loop over a range of values, like when we have an array or a string. And we use while and do-while loops in situations where we don't know ahead of time how many times we want to repeat something. Now, irrespective of what type of loop we use, there are 2 additional tools we have at our disposal. One of them is the break statement that we use for breaking out of a loop. The other is the continue statement that we use for skipping an iteration. Let's see this in action. So here we have a for loop for printing the numbers 1 to 5. Nothing new so far. Now let's say if I is divisible by 3, we don't want to print it on the terminal. So here we can type an if statement and say if I modulus 3 is not equal to 0, then we want to print I. So if you run our program, we only see 1, 2, 4, and 5. We don't see 3, right? Now there is another way to solve this problem using the continue keyword. Using the continue keyword, we can skip an iteration. So anytime I is divisible by 3, we can skip that iteration and go to the next iteration. So here we can change our condition and say, if I is divisible by 0, then we're going to continue to the next iteration. Otherwise, we're going to print I on the terminal. This is another way to solve this problem. But as you can see, the previous solution was more compact. Now we have 1 extra line of code. But there are still situations where the continue keyword is useful. Doesn't mean you have to completely throw it out the window. Now, we also have the break keyword that we use for breaking out of a loop. So if this condition becomes true, then using the break keyword, we can break out of this loop and our loop will terminate prematurely. So now when we run this program, we only see 1 and 2. Now you might be wondering, what is the purpose of this? If we only wanted to print 1 and 2, why did we have to go through all this effort? We could simply change our loop condition and print the numbers 1 and 2, right? That is true. But quite often we use the break statement in infinite loops. Let me show you an example. So earlier, we wrote a program to continuously ask the user to enter a number between 1 to 5. And there we had a problem. We had to repeat our condition in 2 places. So let's see how we can improve that program using an infinite loop. So if we type a while loop and use the value of true for the condition, we're essentially creating an infinite loop. This loop will never terminate. So if we print number and then run our program is going to run forever. So this is an infinite loop, which is something you have to be careful with. But infinite loops are still useful in solving a lot of problems. So over here, we can declare an integer and read the user's input. Now we can have a condition to see if this number is within the range we want. So if number is greater than or equal to 1, and it's also less than or equal to 5, that means this is a valid number. So using the break statement, we can break out of this loop. Otherwise, we can print a message like error, enter a number between 1 and 5, followed by an endo. Now, if we run the program and enter any values outside of this range, we get an error, but the moment we enter a value between 1 to 5, our program terminates. Now, compare this implementation with the earlier implementation. In this implementation, there is only a single place where we have implemented our business requirement. We haven't duplicated this condition in 2 places. This is the benefit of using an infinite loop along with the break statement.